Okay, let's just jump right into it. So this is the Edexcel June 2025 paper for higher GCSE Maths paper 3. So we'll jump straight into it. The video will be timestamped as well, so you can jump through questions. So the first question is a frequency polygon question. So this table shows information about the distances that 60 people travel to work. So we've got distance intervals in the first column, and then we've got the frequency in the second. And it says draw frequency polygon for the information in the table. So first things first, we need to find the midpoint of each of these intervals because we can't really draw an interval, we need one single point. So if you can't figure out what's in between 0 and 10, you can add them. So 0 add 10 and then divide by 2, which is just 5. Likewise, 10 plus 20 is 30. 30 divided by 2 is 15, and so on. So I'm just going to populate. In between 30 and 40 is 35, and in between 40 and 50 is 45. So these midpoints are what we're plotting on the x-axis here. So it would have been labeled in the exam. I just forgot to put that on. So that's distance, and that's d miles. Slightly thicker. Okay. So that's what we're plotting on the x-axis, and the frequency is what we're plotting on the y-axis, which we could see there. So the first one is 5, 12. So 5 is in between 0 and 10, and then 12 is up to there, because each box just represents 1 on the y-axis. The next point is 15, 25, which is right here. We've then got 25, 10, 25 along the x-axis, and then 10 up is right here. I've done that, done that, done that. We've then got 35, 8, so 35's here. 8 is up here. And then we've got 45 over here at 5. Okay, and then to get your final mark with the frequency polygon, you have to join all the points up together. So I don't have a rule on this, but I'll somewhat do it accurately. Okay, so using your ruler in the exam, you would just join all these points likewise together. So it's a bit tricky to do on the tablet, but it would look somewhat like that. So you're just joining all the points together. Nice and simple 2 marker. Let's move on. Question 2. So Ben is trying to make M the subject of this here. So P equals M over 3 plus 5. His is working out. Ben's answer is wrong. What mistake has he made for 1 mark? So let's go through what he's done. Okay, so he's minus 5 to the left-hand side. So he's brought this over to the left-hand side, which is perfectly fine. So that's right. He's then times by 3 on the left-hand side to get rid of this denominator here. But he's not times all of this by 3. He's just put a 3 in the front. So the mistake he's made is he's only times 3 to P, and he's not done it to minus 5. So what he should have done on that step is he should have said 3 times P minus 5 equals M. When expanding that, 3 times P is 3P, 3 times minus 5 is minus 15, and that equals M. So the mistake he has made is incorrectly multiplying by 3 on the left-hand side. I'll just write like that, just for the sake of this. Okay, part B, factorize fully this expression here. I'm just going to write here 2x cubed y plus 4xy squared. Okay, so let's see the common numbers and the common letters. So the maximum number I can pull out for 2 and 4 is 2. And then the x's, we've got x cubed in the first one and we've got x in the second. So the only amount of x's I can pull out is just 1. I've got y in the first term and I've got y squared in the second term. So the minimum amount of y's is just y. Okay, 2xy times something gives me 2x cubed y. Well, the 2 is fine, the y is fine. I just need to times by x squared in order to get that term. 2 times 2 is 4, so that's where that comes from. We already have the x, so that's fine. And y times something gives me y squared. That is just y. So nice and straightforward. Just do it in parts. Look at your numbers and each letter separately. Nice 2 marks there. Okay, question 3. Mia pays £25 for 200 oranges. Okay, I'm going to highlight this information because it's good practice. So £25 for 200 oranges. She puts oranges into bags. She puts 5 oranges in each bag. So one bag has 5 oranges. Mia sells the bags of oranges for £1 each bag. Work out her percentage profit. Okay, so we need to figure out how much bags she's selling. So if she's got 200 oranges and she can only, in each bag, she's got 5 oranges, we're doing 200 divided by 5. That is just 40. So she's got 40 bags, basically, for that. It's quite a good habit as well to write down. So I've highlighted the information in this case, but you could even write down all the information as well if it makes it easier for you. Okay, so she's got 40 bags. Now, each bag she is selling for £1. So I could say 40 bags times £1, just to work out how much is she making, and that's just £40. So she has sold £40 worth of oranges. Well, the amount of oranges that she paid for them was £25 out of her own money. So to work out percentage profit, so what do? The price that she's made, which is 40, minus how much she spent, which is 25, divided by what she has spent, so essentially your starting amount, which is 25. And because it's a percentage, we are timesing by 100. So putting that in your calculator, you get 40 minus 25. There's a calculator paper, by the way. Times by 100, we get 60%. Nice and straightforward. And I've displayed my working out quite nicely for the 3 marks there. So it's good practice to also display your working out like so. Okay, question 4. In London, 2 kg of carrots cost £3.75. I'm going to write the information down this time. So in London, we've got 2 kg of carrots, which is £3.75. And then in New York, so I'm going to just put that here. In New York, we have £5 of carrots for 4.90 US dollars. I'm just going to put a dollar sign there. Okay, so I don't have to write US dollars. They've given us some conversions here, so they've told us how much pound equals and how much kg equals. In which city are carrots better value for money, London or New York? Now, there's different ways you can do this. Either you can change the pounds to kg, or you could change the kg to pounds. They both need to be in the same units. And second of all, you need to change the currency to be the same. You've got one in dollars, one in pounds. So you need to change one of them to be the same. So you've got 2 different conversions to make here. Okay, so I think the best thing to do, I'm going to, since there's 1 kg, which is 2.2 pounds, I'm going to start off with that. So 2 kg, we know 1 kg is 2.2 pounds. So I could divide this side, so just this side, not divide, sorry, times by 2.2. Because 1 kg is 2.2 pounds. So I can times that by 2.2 to change this kg to pounds. So 2 times 2.2 is just 4.4. We've now changed that to pounds. I'm not going to write carrots again. It's just the weight. And that's £3.75. Okay, so now I've got both the London and New York, both in pounds. So that's easy to compare now. The next thing we need to change is the currency. We need to either make them both dollars or pounds. But again, we've got £1 is 1.2 US dollars. So I might as well change this one to US dollars. It'd be a lot easier. So if £1 is 1.2 dollars, we can times this by 1.2 to change it to dollars. And we get 3.75 times 1.2. We get 4.5. I'm sorry, 4.50, and that's still 4.4 pounds. That's perfect. We've got all of these in the same units now as each other, so now we can compare. But there's one issue. We can't compare right now because I've got 4.4 pounds on one side and I've got 5 pounds on the other side. So we need to make them both the same so we can compare which one's better value for money. So I can just change them to both of them to £1. Shouldn't put an S there. £1 of carrots to work out how much each of them are for just £1, and then I can compare them since it's the same weight. Now, how do I get from 4.4 to 1? I just divide by 4.4. Remember, with proportions, whatever you do to one side, do to the other side. So I'm dividing that side by 4.4 as well. So 4.5 divided by 4.4 gives me 1.022 72727. So I'm just going to round it to 2 decimal places because it's money. So I get 1.02 to 2 decimal places. You can even put that down if you wanted to as well. Okay, let's do the same to New York. So how do I get from £5 to £1? I divide by 5. Likewise, I do the same on this side. 4.9 divided by 5. I get $0.98. Don't have to round that. It give me a nice number for that one. So now all I have to do is just compare these two. So which one's better value for money? Basically, what is cheaper? And this is cheaper here. So you would say New York is better value for money because it's cheaper. So again, there were so many different ways you could do this. You didn't have to change them both to pounds. You could even change them both to £5, or you could change the pounds to both kg and compare the kg. You could change them both to pounds, but it seemed easier to do it this way. But you could do it in any way. So that's a nice simple 4 marks. Okay, moving on. Question 5. Kareem rounds a number n to 1 decimal place. The result is 23.8. Complete the error interval for true marks, so 23.8. So a few different ways again to do this, but this is why I do it. To 1 decimal place, so the highest number it could have potentially been was 23.9, because that's to 1 decimal place. And 0.1 less than 23.8 is 23.7. Now our error interval is what's in between these numbers. So in between 23.7 and 23.8 is 23.75. Likewise, what number is in between 23.8 and 23.9? That's 23.85. Now, if you can't spot that, you can add these two numbers and then divide by 2 to find the middle if you can't spot it. And you can use that as well to double check. That's not how you write error interval though. Error interval for n. So n is less than 23.85. Remember, it can't equal it, because if it equals it, then this 5 can round the 8 up to 9, and we don't want that. We want 23.8. That's the reason why we don't have the equal sign under there. However, n is more than or equal to 23.75, because again, if this was equal to 23.75, the 5 would round up the 7 to an 8, which is what we want. That's the answer. Okay, so that's the error interval for question 5. Moving on to question 6. A plane takes 2 hours and 24 minutes to fly from Luton to Alicante. Well, that's not relevant, but okay. The plane flies a distance of 1,512 kilometers. So we've got distance and we've got time. Work out the average speed of the plane. So as soon as you see that, you should know speed equals distance divided by time. So you won't get given that, or you could use a triangle to figure it out as well. It's in alphabetical order, DST, so you could also cover the S and you can see speed equals distance divided by time. So we just need to plug in the numbers here. Now, be aware, it says give your answer in kilometers per hour. So our distance is already in kilometers, which is good. We don't need to convert that. So distance is already 1,512 kilometers. Whereas with the time, we've got 2 hours and 24 minutes, which is an issue because we do not want minutes. We just want it in terms of hours. So let's change it to hours. We've got 2 hours and 24 minutes. Well, 2 hours, I'm going to change it all to minutes first. So 2 hours is 120 minutes because 1 hour is 60. 60 times 2 is 120. Then 120 plus 24 gives me 144 minutes. Now, this is what I need to convert to hours. Now, to convert from minutes to hours, we just divide by 60. So 144 divided by 60, that gives me 2.4 hours. Again, check your answer makes reasonable sense. Like 2 hours and 24 minutes, 2 hours, 2.4 hours makes sense because 2 hours and then the 0.4 represents a 24 minutes. Okay, so we've got all the units that we require now, so we just need to plug it into the equation. Speed equals distance, which is 1512, divided by time, which is 2.4 hours. Putting that in the calculator, 1,512 divided by 2.4, we get 630 kilometers per hour. It's a nice 3 marker there. Moving on, question 7. So ABC is a straight line. So I've just drawn it out again, but this is what was in the exam. And as you can see from the diagram, we've got point A, point B, and we've got point C, which we don't know. It's told us the coordinates here. So A is 2, 7, B is 8, 12. And they've told us BC is half the distance of AB. So if we worked out the distance of this here, then BC would be half that. That is what it's saying. Okay, find the coordinates of point C. So we need to figure out how much is it moving from A to B in both the X direction and the Y direction. That's our first step. So let's write that down. So in the X direction, and remember this is from A to B because they've told us BC in terms of AB. In the X direction, to see how much it's moved from A to B, I'm going to do the difference between the X coordinates, which is just 8, which is the X coordinate in B, minus 2. So that just gives us 6. Let's do the same for the Y coordinate. So for the Y direction, we've got 12 minus 7, just gives us 5. So remember, this is from A to B in terms of the X and Y direction. Okay, now that we know BC is half AB, we can change both these numbers by half, basically. So for BC, because it's half AB, the X direction is going to be half of what we've just found, so half times 6. And for the Y direction, it will also be half the amounts, which is half times the Y direction, which is 5. Half times the 6 is 3, and then half times 5, I can just say 5 over 2. Okay, so now that we know how much away from B C is in terms of the X and Y, all I need to do is I just need to add these to this coordinate here to find out the coordinates of C. So from coordinates, B was 8, 12. So B being 8, 12, I would just say C. So for the X, it's 8 plus 3, which is here. And for the Y, it's 12 plus the Y direction, which is 5 over 2. And that just gives us 11 and 14.5. There you go. That's how you do that for 3 marks. Moving on to question 8. We've got a trapezium. We've been given 2 of the sides. So we've got AD, which is 8, and we've got AB, which is 12 centimeters. It's told us the trapezium has an area of 112 centimeters squared. So keep in mind the area formula of a trapezium. So I'm just going to write that down since it's here. So area of trapezium, it's a half times A plus B times H, where A is H. So I'll just label it, this is H. And we've got A, B are the parallel sides. We'll call this A and I'll call this B, but it doesn't matter which one you call A and B. Okay. Okay, so it looks like we know H, we know A, but we don't know B. But it's told us area. It says work out the perimeter of the trapezium, give your answer to 3 significant figures, and it's a 5-mark question. Now, in order to work out the perimeter, we need to find out what is this side length here and what is this side length here. Now, because we know the area of the trapezium, let's work with that first. So the area of the trapezium is a half times A plus B. Now, we know A is 12. We do not know what B is, so I'm going to write plus B times H, which is 8. And we know that the area equals 112 centimeters squared because they've told us. So we're just going to solve this equation to find B now. So a half times 8 is 4. So 4 times 12 plus B equals 112. To take the 4 over to the other side, the opposite of times is divide. So 12 plus B equals 112 divided by 4, which gives me 28. Now to get b by itself, I need to get rid of that 12. To get rid of that 12, I'm going to minus it over to the other side. b equals 28 minus 12, which gives me 16. Okay, perfect. So I've got b. I know that this top side here is 16 here. So I can just write it here, actually. I'll call it DC. So I know DC is 16. Now I just need to find this side over here. So we've not really got any other information in terms of like area or anything. So we need to figure out how to use something different to find out what the length of that slanted is. Now what you can do is you can split this and I can pull out a triangle at this point here. So I'm just going to draw the triangle down here. Okay, and what do we know about this triangle? We know it's a right angle because we just split it from the top. We also know that this height here is going to be the same as this height. So it's going to be 8 centimeters that side. We also know this full length here is 16 and this length here is 12. So 16 minus 12 is just 4. So that is 4 up here. This little section over here is 4. I'm going to put that on the shape instead down here. Now we can use Pythagoras' theorem on this triangle to figure out what is this slant here. And if we find that slant, we know that length, and then we can find out the perimeter. Let's use Pythagoras. Now, what does Pythagoras' theorem say? Pythagoras says a squared plus b squared equals c squared, where I'm going to, c is the hypotenuse, which is what we're trying to find, and then these are a and b. So plugging that straight in, a squared, which is 4 squared, plus b squared, 8 squared equals c squared. So to get c by itself, I'm going to square root my answer. And what I get is square root of 4 squared plus 8 squared is 4 root 5. Okay, so I have now found this side here. So I'll just say BC equals 4 root 5. So now I can work out the perimeter because I know all the lengths of each side. So the perimeter is just going to be 8, which is this, plus 12, plus 4 root 5, which is a slant, and plus the top length, which we found was 16. Adding these all up together, we get, from here, we get 44.9 centimeters to 3 significant figures because the question has asked for it to 3 significant figures. That's a nice 5-mark question there for question 8. Moving on, let's do question 9. Okay, so we've got a standard form question here. It says write 5.73 times 10 to the 6 as an ordinary number. So you just need to move the decimal point. It's times 10 to the 6, so it's going to be a big number because this coefficient is positive. So what I would do is write 5.73, add a few zeros on for now, and you're going to move this decimal point 6 times. 1, 2, 3, 4, 5, 6. So it's going to end up there. Don't need any, oops, 2 seconds, make that a bit smaller. We do not need any of these ones here. So our answer is 573 with 4 zeros. 1, 2, 3, 4. So that's 5,730,000. So the commas just separate out and read it out. Write 0.035 in standard form. Well, in standard form, your first number is always a number between 1 and 10. So I'm going to write 3.5 times 10 because all standard form is always times 10. And since it's a small number, unlike the last one, it's going to be a negative power this time. Okay, so let's see how much the decimal point is moving from here in order to jump here because that's where it is here. It's moving 1, 2. So it's to the power of -2. So it's all about where your decimal point is jumping to figure out how much you're going to times it by. Nice, easy 2 marks there. Question 10 says use your calculator to work out this. So it's testing you on your calculator skills for 2 marks. So all I would say is when putting this in the calculator, ensure that your squared is on the whole bracket That's a quite common mistake. Another common mistake as well is not making sure your cube root is over the whole thing as well. So you could potentially just stick it on your calculator and you'll get the answer. So have a try at it and see if you get this number. So 12.580777014. It says give it to 3 significant figures. I would always recommend in the exam writing what your calculator shows and then rounding it to 3 significant figures, because this is a 2-mark question. So it wants to see what you actually got on the calculator, and then it wants to see your rounding for the 2nd mark. So rounding that to 3 significant figures, that's our 3rd significant figure. So the 8 after that changes the 5 up to 6. So that's just 12.6 to 3 significant figures. Nice, easy 2 marks. Question 11. Got some indices rules here. Find the value of n. Now, we've got all the same bases here. It's all 3. So we can use our indices rules here. If all the letters are the same, if all the numbers are the same, you can use indices rules. So 3n times 3 to the power 20, in terms of the indices rules, that just means n plus 20. So that's for the top numerator. Now, in terms of dividing by 3 to the power of 8, when you're dividing 2 powers, 2 same bases to the power, you minus the powers. So n plus 20 for the top, and then we're minusing by 8 for the bottom. And that just equals 14. So what I've done is, just to reiterate again, the powers here, so I'll just rub that out. So the powers n and 20, because we're timesing on the top, we add the powers. And then dividing, so because we're dividing, we then minus the powers. That's where the -8 came from. And then that just equals 14 because we're comparing all the powers together. Now let's solve this to find the value of n. So n plus 20 minus 8 equals 14 is just n, and then I can bring 8 to the other side actually. N plus 20 equals plus 8 to the other side, I get 22. And then n equals minus 22 to the other side, I get 2. And that's our answer. You can always check your answer as well if you've got time in the exam. Stick in 2, and do you actually get 3 to the power 14 on the other side? If you've got time, so you can always check your answer as well. Okay, part B. 2 marks. Write 64m to the power of 12 to the power of 2/3 in the form a and b, where a and b are integers. Remember, integers just means whole number. So if you end up getting a decimal answer for a and b, you've gone wrong if you've got a decimal or a fraction. Okay, so what do the rules tell us here? Now, this is in a bracket. That means this 2/3 is applying to everything in the bracket. So 64 to the power of 2/3 times m to the power of 12 times 2/3. Now remember, when you've got 2 powers like that, you times them together. So I'm just going to do that to the side here. 12 times 2/3 just gives me, that's 12 over 1. Our indices rules, fraction rule, sorry, just say you times across. 12 times 2 is 24. 1 times 3 is 3, so we've got 24 over 3 for the top. Let's just simplify further. 64 to the power of 2/3, we've got a calculator, stick in your calculator, you get 16. And then m to the power of 24 divided by 3 is just 8. And there you go, that's our answer. Let's just double check. Do we have integers? Yes, a is 16, so the number in front. And then m to the power of b is 8. So b equals 8, so b is also an integer, so we've got it right. Okay, so that's question 11. Moving on to question 12. Okay, so the price of holidays increased by 10%. Okay, so it's an increase. After the increase, the price of the holiday is £440. Jim says that 10% of 440 is 44. So the price of the holiday before the increase was 396. Is Jim correct? Explain the answer. He's worked out 10% of the wrong thing. So let's think. There's a few different ways you can think about this, but I'll tell you one way to think about it. Let's say we've got the holiday. The price of the holiday before is called X. So that's the unknown price of the holiday before. So I'm going to call it X. So if I've got X, which is the price of the holiday before, and I've increased it by 10% the price, our multiplier, so changing 10% to a decimal, that's 0.1. So because we're increasing, remember 100% is just 1. So our multiplier, so adding these two together, we get 1.1. What that is saying is if you do 1.1 times by X, you will get the new holiday price after the increase, which we know is £440. So we can actually work out the price of the holiday before the increase, and if it's different to 396, then we know Jim is incorrect. Okay. To get X by itself, because it's timesing by 1.1, the opposite of timesing by 1.1 is dividing by 1.1. So 440 divided by 1.1, we get £400. So that means Jim is wrong. He's worked it out. He's worked out the 10% of the price after he should have done that from before. Okay, so that's question 12A. And then part B. Tina sells bikes. In November, Tina sold 25% fewer bikes than she sold in October. And then in December, she sold 50% more bikes than she sold in November. In December, Tina sold 180 bikes. How much did she sell in October? Okay, so we've got October, November, and then December. So 3 different months. And there's some unknowns, again, just like how we had an unknown X above. So it's going to be similar to here. So we want to know how many bikes did she sell in October. So this is what we do not know. So I'm going to call that X. So X is the number of bikes that she sold in October that I've got no idea what it is. That's what I'm trying to find. Let's look at all the information. In November, Tina sold 25% fewer bikes than she sold in October. So 25% less of X. So again, we need to find a multiplier. So 100% is 1, as we know. 25% is 0.25. So, and because it's fewer, we're minusing 0.25. And we get 0.75 for that. Our multiplier for November is 0.75 times X. That's how much bikes she's got in November in terms of X. Okay, in December, Tina sold 50% more bikes than she sold in November. So if she sold 50% more, it's now 100%, which is just 1. Add, it's adding because it's more this time. 50% as a decimal is 0.5, so that's just 1.5. So 1.5 of what she sold in November, and November is this number here. So we're just timesing it by 0.75 times by X. So we've got all these 3 months in terms of X now. So we know in December she sold 180 bikes. So we know that we can solve that to find X now because they've told us how much in December she sold. Let's solve that last equation. We've got 1.5 times 0.75. Hold on, I'm just going to work it out. That gives us 9/8 times X equals 180. And to get X by itself, I need to bring 9/8 to the other side. So I'm just going to do 180 divided by 9/8. So X just equals 160. So, and remember we've said X is the number of bikes that Tina sold in October. So probably just write something along the line, number of bikes sold in October. And that's part B. So that's question 12 there for 4 marks altogether. Let's move on to question 13. Okay, here are some graphs. 3, 6, 7, 8. So we've got 8 graphs there. You should recognize what all these graphs are. So the first one, we'll look at the question, then we'll come up and explain it. Each equation in the table is an equation for one of the graphs. Complete the table. So just matching these equations to the letters of the graphs above. Now, just looking at this, so I'd eliminate the ones that you're really comfortable with. This one here, let's just label every single one of these as well. This one here is a cubic graph because it's got x cubed, so they can look like that, 2 ohm, so it could have a point of inflection. We've got a reciprocal graph here. We've got a quadratic here because of the x squared. And we've also got an exponential graph as well. Okay, so we've identified what type of graphs all these equations are. Let's start off with the quadratic. That's pretty easy to spot. And the reason why it's easy to spot is it's a negative x squared. Now remember, with negative x squared graphs, the end shape, so a bit like a negative face. If it was a positive coefficient, it would be a U-shaped graph, so like a smiley face. Okay, so out of the ones above, we need to find one that has an end shaped. Hopefully there is only one, and that is, it's just B. So that third one there would be B. So we've eliminated out B. Okay, the next one, let's do this cubic graph. Now, because there's nothing adding to this cubic graph, like it's not x cubed plus x squared times something, it's just x cubed. So it wouldn't be this one here. So this is a cubic graph, but it would have other like stuff like x squared and x a number. However, it's just y equals x cubed, which you should just recognize as this graph here with a slight point of inflection. So that one is E. Okay, we've then got a reciprocal graph. Let's see how many reciprocal graphs we've got above. So we've got C, and we've also got G. Now what you need to recognize is this is a positive one. So there's no negative sign in front of that. This is a negative one here. So if there was a negative sign in front of that, it would be G. However, because it's not negative, it would just be C in that case. So they've confused you there. That's why they put two different ones. If it's a positive reciprocal graph, they would be on them two quadrants. And if it was negative, it would be in these two quadrants here. So that is just C. And then finally, we've got the exponential graph. Now you should recognize the exponential as going up to infinity. So which exponential graph do we have here? We've only got one positive exponential graph, which is H there. That final one is H, and that's for 3 marks for question 13. Okay, question 14. Here is a triangle. Here is triangle ABC. So we've got two sides. I've noticed that it's not a right angle, so you should take that into note as well. We've got an angle as well. It says calculate the area of triangle ABC. Give the answer to 3 significant figures for 2 marks. It's not a right angle triangle, so the equation we're using is area equals half times AB sine C. So let's label this triangle. Remember, whatever's with your sign, the capital letter is the angle. We've only got one angle, so that's going to be our angle C. And the other ones are going to be A and B, and it doesn't matter which one you call A, and it doesn't matter which one you'll call B. I'm just going to say AB. Let's plug everything into the formula. A half times A, which is 8.3, times B, which is 9.8, times sine C, which is 35. Putting that all in the calculator, we get 23.32735. I would recommend, again, writing your full answer and then rounding it to 3 significant figures to get that method mark. So 3 significant figures, we're looking at that 2, which keeps the 3 as is, so it's just 23.3 to 3 significant figures. I should have put the units there, actually. Since it's area and it's in centimeters, it's centimeter squared. Nice, easy 2 marks there. Let's do this with a probability question. So our options, which is blue and red. Blue is 7, red is 3. So our total is 7 plus 3, which is 10. So that's all the information we need for that. 2 seconds. It doesn't look like it's sharing. Let me just reshare the screen. Oh, it looks like it's there. Perfect. Okay. So blue is 7 and then red is 3. Let me just make sure this is in sync. Yeah, perfect. Raja takes at random one of the pens. He notes the color of the pen and then he puts the pen back in the box. Now the relevance puts the pen back in the box means that the probability after will not change. It will remain the same. Raja does this 2 more times. So he's done it the first time and then he's done it another time and then another time. So that's 3 times altogether. Show that the probability that Raja takes at least 2 blue pens So at least 2 blue pens is this. So it's quite good that they've given us the answer in the question, so we've got something to work towards. So basically in the exam, you would know if you got the answer right or not. Okay, so at least 2 blue pens. So we need to figure out what's all the possibilities. So we've only got blue and red pens, and he's picking out the pens 3 times. So let's say he picks out a red first. If he's going to pick out at least 2 blue pens, then the next 2 have to be blue. So that's our first option. Okay, so that's the first option, red, blue, blue. So he can't pick up another red pen first because there's no other combinations for him to have 2 blues after. That's the only combination, with red pen being the first one. So now let's say he picks a blue pen first. He could pick another red and then a blue. So I've got at least 2 blues there. Or he could pick up blue, a blue again, and then a red. So then that's at least 2 blues as well. Or he could pick up a blue, then another blue. But then the third one, it can be another blue as well because it says at least 2 blue pens. So it could be 3 blue pens as well. And they're our only combinations. So let's work out the probability of each of these. So the probability of getting red is 3 out of 10. Now, because he's picked out the red and he's put the pen back into the box, the probability after choosing the second pen is going to stay exactly the same. So if we're timesing that by the probability that he's going to get a blue pen, which is 7 out of 10. So that's the probability for the second one. And then for the third pen, he's picking out a blue again, and the probability of blue is 7 out of 10. So timesing that all together, you get 147 over 1000. Let's do the next one. So we've got blue, which is 7 out of 10, times red, which is 3 over 10, times blue again, which is 7 over 10. So timesing all them together, again, we get 147 over 1000. Now let's do blue, blue, red. So the probability of blue is 7 over 10 times 7 over 10 times red, which is 3 over 10. Again, that gives us 147 over 1000, same as before. And then finally, 3 blues. The probability of getting a blue is 7 out of 10 times 7 out of 10 for the second blue, and then 7 out of 10 for the third blue. Timesing this all together, we get 343 over 1000. We're not done there yet, though. We've got these 4 probabilities it could potentially be. We need to add them all up together now. And hopefully, we get this answer here. So we're doing 147 over 1000, add 147 over 1000, add 147 over 1000, add 343 over 1000. It's really crucial to show all these steps of working, just because you've already told you the answer in the question, so they need to see you're working out. So adding them all up together, you end up getting 98 over 125. That's a nice 4 marker there for question 15. Let's move over to question 16. The diagram shows a solid shape made from a cylinder and a cone. So I can see the cylinders on the bottom, and then we've got a cone that's just sitting on top of the cylinder. And they've also told us the volume of the cone in the question as well. It says the cone has a base radius of 8 and the cylinder has a radius of 8, which makes sense. It's sat on top of each other. So if that's 8, then this on the bottom here would also be 8 as well. It says the vertical height of the cone is 3 times the height of the cylinder. So let's say the cylinder height is h, then that means the cone height is 3 times h because it's 3 times the height of the cylinder. It says the volume of the solid shape is 640 pi centimeters cubed. So this whole shape, the volume is 640 pi centimeters cubed. I'm just going to leave it like that though. Okay, so we've got the volume here. Work out the vertical height of the cone. Okay, so we know the entire volume of the solid shape is the volume of the cone plus the volume of the cylinder. They told us the volume of the cone. How do we work out the volume of the cylinder? How do you spell cylinder? Cylinder. Okay. So it would be the area of the face of the cylinder, which is a circle, which you should know as pi r squared. And then we're just timesing that by the height, so h. So we've got both the volume of the cylinder and the volume of the cone. We are going to add them two together to give us 640 pi, but I'm going to substitute the numbers as I'm adding them together as well. So the volume of the cylinder is a pi. I'm going to do it in purple, actually. Pi times r squared. R squared of the cylinder is just 8 squared, so 64, times the height, which is just, we've called it h. And then we're adding that to the volume of the cone, which is a third, times pi times r squared, which is again is 8 squared, which is 64, times the height, but this time it's 3h because it's 3 times the amount of what the cylinder is. And we know the total of these two volumes is going to give us 640 pi that they've told us in the question. Notice how I'm not timesing out by pi because I'll just get loads of decimal numbers to work with, which will get ugly quick. Let's simplify this. We've got 64 pi h. For this, we're adding to a third times 64. That's 64 over 3. Oh, we've actually got the 3 there as well. I missed that 3 here. So it cancelled. So these two cancel each other out. So we're just left with 64, not 64 over 3. 64 pi h equals 640 pi. We can combine these two together. 64 add 64 gives us 128 pi h equals 640 pi. I can cancel pi from both sides. So I'm left with just 128h equals 640. And then to get h by itself, I'm just going to divide the other side by 128. So 640 divided by 128 gives me 5. But that's not our final answer. So we found h. What is h? We've said h is the vertical height of the cylinder. The question said work out the vertical height of the cone, which is 3 times h. So the vertical height of the cone we've said is 3 times h, which is 3 times 5, which is 15 centimeters. That's our final answer for 4 marks. Next question, got algebraic fraction. It says solve this algebraic fraction so it's equal to 1. Now, first things first, with these, we need the denominators to be exactly the same. So we've got 3x minus 1 on this side, and we've got 3x plus 1 on that side. I'm going to times this fraction here by 3x plus 1 on the top and bottom. And I'm going to times the second fraction by 3x minus 1 on the top and bottom. Let's do that. The reason why we're doing that is because we want the same denominators, so we can combine it all to one fraction, because right now it's 2 separate fractions. Okay, so this first one here, 5x, remember we're timesing by 3x plus 1 on the top. And then on the bottom, we've got 3x minus 1 times 3x plus 1. Now remember, if you times the top and bottom by the same thing, you've not actually changed the number, it's the same thing, because 3x plus 1 over 3x plus 1 cancels out, they're gone. But we're timesing them both by that so we can combine them together. So that's the reason why we're doing it. So a lot of kids get confused with that. Then minusing 2x, this time we're timesing by 3x minus 1. So if I've times the top by 3x minus 1, I'm timesing the bottom by 3x minus 1. So as you can see, both denominators are now exactly the same, so we're going to combine them together. So that just equals 1. So I've just rewrote the top equation. I've just times each of these up. Now we can combine together. Before I do that, I'm going to expand the brackets. Or we can combine them together and do that as well. So that's fine. 5x times 3x is 15x squared. 5x times 1 is 5x. Minus 2x times 3x, which is 6x minus 6x squared. And then minus 2x times minus 1. Minus times a minus is a positive. And then we've got 2x. All over 3x times 3x. Remember, these are both the same, so I'm just writing it under the same one. 3x times 3x is 9x squared. 3x times 1 is 3x. Minus 1 times 3x is minus 3x. And then minus 1 times 1 is just minus 1. That equals 1. Let's collect the like terms on the numerator and the denominator. 15x squared minus 6x squared is 9x squared. And we've then got 5x plus 2x, which is plus 7x, over 9x squared. 3x minus 3x is 0, x, that's gone. And then we've got minus 1, and that equals 1. To solve this, I'm going to bring the denominator up to the right-hand side. So I've got 9x squared plus 7x equals 1 times this denominator is just a denominator, because 1 times anything is just itself. And now we just need to bring all the x's over to one side. So this x squared, if I minus it to the left-hand side, 9x squared minus 9x squared, that's cancelled, that's gone. So we're left with just 7x equals minus 1. And to get x by itself, it's got that times 7. So the opposite of times 7 is divided by 7. We've got minus 1 over 7. And that's our final answer. So for 3 marks. You can always check your answer as well if you've got time. Plug in wherever there's an x. Plug in